So by your spirit I will rise from the ashes of defeat. The resurrected King is resurrecting me. By your name I come alive to declare your victory. Come on, say, the resurrected King is resurrecting. Say, by your spirit I will rise from the ashes of defeat. Come on, say, the resurrected. This is what he's doing this morning. He's resurrecting. By your name I come alive today. Every dead thing, I speak it, every dead thing. You gotta come alive today. Because the resurrection power is here.
Good morning, everyone here. Yes, it's been a rather hectic morning for me since I've gotten up because I gotta bring wife to work, and then I have 2 kids with me, 3 year old, 6 month old, and as it is right now, even the 6 month old is calling for my attention. So I'm gonna have to multitask a bit, but I am here. I am seeing, let's see, by count, myself included, 17 persons. And of the 17, at least 3 I can identify as not being students. So see, 18, so far 15 persons are here. I guess the numbers would grow as we proceed. All right, but I'd like to welcome back persons who were here for the last session of Csec Physics. And for those who may be new to the channel, I'd just like to welcome you to the Miketown Seventh-day Adventist Church District Initiative that see students such as yourselves benefiting from this endeavor, especially for the fact that exams are right around the corner, and you can greatly benefit from whatever it is that we intend to go through this morning. I just want to be sure that persons are seeing my video good and hearing my voice clearly. So by way of a confirmation of yes, sir, or yes, can somebody just say the shout out real quickly that you're hearing me? So I don't want to assume that.
Yes.
All right. All right. I don't know if the signal on my end is broken, but yours was a bit. So ensure, I'm gonna check I'm keep checking my signal as it is right now, because you know how this Wi-Fi thing is, Wi-Fi is here now and then gone another second later and all of that. So just ensure that your Wi-Fi/data connections are secure and your devices are operational enough so as not to miss a beat. All right. I have been asked by the pastor of the district to start out with a word of prayer, and then we go into the preliminaries, and then we'll get to that. So I'm gonna ask that you bow your heads, symbolically or literally, wherever you are, as we pray. Father, we ask that you be with us at this time. We ask that as we go forward with this endeavor, that you will be with the presenter and the participants in a special way so as to ensure that whatever is exchanged, whatever is discussed, it will be to the clarity and to the edification of the persons, the stakeholders herein. We ask that as we go through our little activity that we are contemplative of who we are and whose we are. Forgive us where we have fallen short. Bless us now, we pray. Amen. All right. So I was also asked to let persons be aware that this is being streamed live on YouTube. And I think more than likely, yes, while it is being streamed, it is also being recorded. So you can refer back to it under the Town District of Churches channel, and you would be able to find that which we would be going through now. All right, so the last time we looked at the most recent 2019 paper one, and I see a few chats here. Right. Okay, good. It's just persons confirming. Right. So as I was saying, last time we were looking at the 2019 paper one. We went through it with its entirety. And for the most part, persons were able to give the correct answer as we went along, which was good. Um, some, I don't know if it was guessing or you knew the answers prior, but what I always encourage students to do is that when it comes down to answering questions, don't just try to rely on past paper questions and answers. Even though the truth of the matter is CXC does do repeat questions, they do, unavoidably so, because paper one questions are really difficult to set, right? To set them properly is really difficult. So what you'll find is that questions will repeat from year to year. So you can call that somewhat unavoidable. But my advice to you is that don't just go in hoping that you will find repeat questions from 1 to 60. Go in there with the mindset that you are going to work through those questions. You are given hour 15 minutes, right? 75 minutes to work out 60 questions. So by the math, that's like 1 minute 15 seconds per question, roughly thereabout. So it's not for you to just go in and rush. No. Take your time, pace yourself, ensure that the questions that you're answering are as best as possible answered correctly, to your best estimate, and try to make sense of what the question is asking. When they ask you a question, don't just hope that all right, the answer will just pop out at you, or you've seen this already, so you know the correct answer. Work through it, make sense of it. All right, that's just my advice to you. But if you see repeat questions, more power to you. Don't get me wrong. That would be like, yeah, good for you. But just try to, try to work it out. Because this is physics. And if it wasn't for COVID, you'd still have paper two to go and tackle with. So yeah. So that out the way. It's nine past. So as I asked before, I'm gonna ask the question now. I soon start screen sharing and all of that, but what I want to find out from you, do we work on let me just start sharing my screen here. This mouse is not working with me at all. Hold on. Let's make sure that I get this right. Right. So I just want to ensure that persons are seeing what they ought to be seeing. So as it is right now, I have on the screen the folder with the different multiple choices that I have available. I have the 2019. We had worked through the 2019, but We didn't go through the 2018 any other question. So should I take it that we go through the 2018, or is there a special year you want to look at? And that's a question to anybody. Hello? Are we hearing? All right, let me see what the chat is saying. Hold on. All right. So I see in the chat here 2018. All right, no problem. So we work with the 2018 then. Where is it? So let me just bring up that 2018. All right, so we're at 2018. All right. So by confirmation, are we all seeing this?
Yes, sir.
All right, good. Lovely. So we're seeing it. All right, so let's go straight into it. Errors due to parallax can be minimized by I know you all like to text, you know, it's a texting era, but I'd prefer a person start back to me. All right, because it's gonna be hard for me to navigate the page while paying attention to the text. It's extremely blurry. All right. Let me see if I can fix that blur. I'll probably have to zoom it. I don't know if that fixed the blur. Did that fix the blur for that person who had the issue with the blur? Okay, it's better now. All right, good. So let's go back to it. All right, so errors due to parallax can be minimized by A, B, C, D. Taking more than one reading, placing the eye at right angles to the mark being read, taking readings from different angles, taking an average of 2 separate readings. Don't see anything in chat, nobody. I'm not hearing anyone.
Is it B?
B, all right. Placing the eye at right angles to the mark being read. All right, well, yes, the answer there would be B, because taking more than one reading doesn't minimize parallax. Parallax is a point of view error, and being a point of view error, it therefore means that it's all based off vision, line of sight. All right, so none of the three, A, C, or D, would give a minimization of that error. It would be B. So we move on. Which of the following measuring instruments is most suitable for accurately measuring the volume of 40.2 cm cubes of a liquid? Most suitable for accurately measuring volume. Which instrument? They all measure volume, you know.
Measuring
Right?
cylinder.
Is it D?
All right. Some persons say measuring cylinder.
Can I get the back and strip your bed, please?
Say again?
Can I manage your washing?
I don't know if that was meant for me. The last person who spoke. All right, let me just go with the answer that you gave, D. All right. Here's why D would not be the most suitable. Typical measuring cylinders, they measure up to the nearest cm cube, right? If you look at measuring cylinders, the markings, each of the markings is the smallest mark measures up to a centimeter cube. This value of 40.02 is less than a cm cube. So you'd want an instrument that reflects markings that are less than the centimeter cube. All right. The best one there would actually be the burette. Because for chemistry persons, you know that when you're titrating, for chemistry, you know what I'm talking about. But titration is basically mixing acid with base, all right? To find the endpoint, you know, the color change and all of that. So when you're doing that kind of chemical reaction type thing, you want to have accurate measurements of volume. And as such, you use a burette. It's not that you couldn't use a measuring cylinder, but a burette is specifically built to allow water to run out, liquids to run out. And when you read in a burette, you can read up to zero point 0.1, I believe, of a cm cube. All right, the pipette can measure volume, small volumes, but only based of a standard 25 centimeter cube. The only mark on it is the 25 cm cube or whatever the pipette is. The beaker, that's even worse because typically measure like 50 cm cube graduations. The measuring cylinder can measure small volumes, but for the 40.2 cm cube, the 0.2 there indicates that you need something that is able to measure beyond or smaller than the centimeter cube. So the only instrument there would be the burette. All right, let me check the chat. Nobody sent a message there. All right, hold on. Let me see if I can toggle quickly to the chat. No, that didn't work. No. All right. All right. So the answer there would be A. All right. We proceed.
Hello, sir.
Yes. Morning. Somebody had something to say? No? All right. We proceed. Which of the following changes can be caused by a force acting on a body? Shape, motion, density.
A, sir.
A, 1 and 2 alone. All right. Any other answer?
D.
D. All right. 1, 2, and 3. All right. So I'm gonna have to probably put persons on the spot here, but for the persons who said A, why would you say it is only shape and motion? Why not? Why not include density?
For me, the reason I chose shape and motion is
Uh,
because just because the force acting on our body
uh-huh.
can change it in the shape and body, it doesn't
Right.
necessarily mean that the molecules get closer together and denser.
Okay. All right. Well, here's the thing. It didn't specify what body you're talking about here. It could be a liquid, it could be a gas, it could be a solid. But can I tell you that this can cause elongation, expansion, and forces can cause contraction or reduction in internet connection is stable. All right. Are you hearing me? My message just came in that internet connection is unstable. Are you hearing me? Hello, is everyone hearing me?
Yes.
Yes, sir.
Yes, sir.
Okay, lovely. All right, because I just got a message that my internet connection was unstable. All right, so as I was saying, forces can, yes, shape and motion are in. All right, so the issue is here if 3 density is a part of it. So the answer would be yes. Why? Density is dependent on mass and volume. Won't change the mass, right? Because mass, change in mass means that you're breaking off or you're adding pieces of the object. So when it comes down to the volume, when you apply a force, you can cause something to get bigger by expansion, meaning that you can cause literally the object to size by way of the force as well. If you don't believe me, look at how a gas is. For you to compress a gas, you apply an external force on the gas and it becomes smaller in volume. The issue with liquid and solids is that is not to say that they're incompressible. Strictly speaking, anything can be compressed, but you just need the right amount of force. All right, and by compression, I mean even the slightest change in decrease in volume. but they say that solids and liquids are virtually incompressible. Reason being is because they require an extremely large force, extremely large pressure for you to compress them. But generally speaking, you can change the density of something by applying a force. So shape and motion are in, and density is also in by, because you can change the volume and thereby the density of an object by applying a force to that object. Not all objects, and if it is going to be all objects, it's going to be like any level of force, pressure, but when you talk about a gas, because they didn't specify liquid or solid, so you have to assume all states of matter. When you talk about a gas can be compressed and thereby its density can change by way of a force. So the answer there would actually be D, 1, 2, and 3. All right, I believe this is a repeat question. It looks repeat-ish. I've seen this before. I don't know if it was in the 2019. But number 4, the mass of an astronaut in the Earth, his approximate weight would be.
Sir, the screen is a bit blurry.
Yeah, all right. Let me see if I can turn down the brightness a bit there. I don't know if that helped. I don't know. Talk to me, somebody. I'm turning on the brightness. Is that better or worse?
No,
Or,
sir, it's not
I
better.
don't know, screen share, would it affect that? Not better. All right. So that means that is the quality of the file itself. All right. How would I fix this? View. Let's see now. Edit text and images. That didn't work. Honestly, this is just the Adobe PDF reader. I don't know. If it was a JPEG file, I could change the contrast a bit. But
hello, good afternoon, sir.
I'm not so familiar with editing the display.
You hear me?
Hold on. Yeah, I'm hearing you. Go ahead.
One question. I just joined the group for 10 o'clock math class, but I think you're doing a different subject.
Yeah, man. This group is for Csec physics. The math was done on Monday. The math was scheduled for Monday, so that has gone already. Today is physics.
Okay. All right. Thank you, sir.
Yeah, man. So do you do physics?
No, sir.
Yeah, man, no problem.
Not this year.
Is he gone? I don't know. Oh, you don't know physics. All right, no problem. This is for physics. The math gone already.
All right. Thank you.
Yeah, man, no problem.
Mr. Teacher,
Yes, sir.
maybe he could check the Microphone S.D.A YouTube page.
Right. Well, I don't know if he has gone already, but yeah, he could, because it would have been recorded from Monday. So whatever was done then, he could access it on YouTube. I did remember to say that to him. All right, but if he's still here, or if somebody knows him, you could just pass that message to him. Failing that, what I'll do, I'll just ask the pastor to indicate to all persons that, you know, who was looking for it, that they could come and access it from YouTube. All right.
You may proceed. You may proceed. I will just send the link in the chat.
Yeah, no problem. Yeah. All right, no problem. All right, I'm not seeing it here. I'm really not seeing that. I know that this is a bit blurry. I can understand that because even looking at it right now. All right, let me see if zooming it even more fixes it. All right, how about that? Is that clear now?
No, sir.
No, sir.
Still blurry?
Yes,
Oh.
it's sorry.
Okay. All right, this is a challenge. This is a challenge. All right, hold on, let me see. 2018, 2019, 2016. What about this one? I brought up the 2016 paper. Is this good?
Sir, it's not just the paper. Overall, when you're sharing, everything is blurry.
Oh, wow. I see. But that wasn't the case when we were doing this last week, was it? I'm asking, for those who were here last week, was it a case that it was as blurry?
No, sir, it wasn't as blurry last week.
It wasn't that blurry. All right. That means that something happened between then and now. But it's the same machine I'm using, same everything. I don't know. I really don't know what's happening with that.
Maybe you can try stop share and try
All right,
again.
let me see if I can stop the share and then restart it. iPad, Zoom cloud meetings. How about now?
Much better, sir.
Okay, excellent. All right, so all right, that was a 2016. This is a 2018. How about now? Is it better now?
Yes, sir.
Excellent. All right, so that fixed it. Thank you for that suggestion. All right, we resume. Number 4, by now you should know this answer.
It's 700 newtons.
700 newtons, correct? The mass is 70, gravity on Earth is 10. Mass times gravity gives us 700. All right, we're on to number 5. The moment of a force is defined as, this is also a repeat question. I'm sure I saw this before. I don't know if you did, but seen this recently. Number 5.
See?
C.
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 Is that C?
Yes, sir.
Product of the force and its perpendicular distance from the turning point, correct? So that's C. Item 6 refers to the following diagram, which shows two forces, X and Y, applied to an object. What should be the magnitude and direction of a third force, which will cause the object to remain stationary? So we're looking at balancing X and Y. So what's the magnitude of it and what's the direction?
Is it X plus Y to the right?
X plus Y to the right, no.
X minus Y to the left.
X minus Y to the left, no.
X
X
plus
minus
Y
Y
to
to
the
the right? Or, okay.
X plus Y to the left.
X plus Y to the left, yes. X and Y are pointing to the right, because, yeah, to the right. And for you to balance it, you need a force that points to the left. That's the first thing. All right, and then the second thing is that the forces, that force must be the value of the sum of the X and Y forces. So it is X plus Y to the left. All right, because the forces there are pointing to the right. So the answer there would be B. When a force F is applied to a spring of original length L, the new length becomes L plus X. What would be the length of the spring if a force of F over 2 is applied instead?
A, sir.
A? All right, I'm gonna give somebody else a chance to select
Sir,
another
D.
one. Say again?
D.
B as in boy?
D.
Is that B as boy or
Dog, sir.
dog? All right. Yeah, the correct answer would be D. Why it is not A? Remember, Hooke's law tells us that force and extension are directly proportional. So if F causes an extension of X, then half of F, which is F over 2, would have to cause, by proportionality, half of the extension, which is X over 2. It's not twice the X, all right? So it's not B, because that's like doubling the length and the extension. It's not C, because the extension will be different. It's not A, because the extension will not double, the extension will be half, so it is therefore D. Number 8, and I think I need to zoom it for this one. It shows now a caliper, and you have to read the reading of the caliper. So I want for you to look at that, and then we'll look at the, well, you looking at it, tell me what the answer would be. All right? I need for you to tell me what the answer would be.
12.25 centimeters.
12.25. All right, that's one. Any other reading? Nobody? All right. I guess we'd have to read and work through this then to show you what the answer really would be. I'm trying to find, all right, I hope that you'd be able to see the crosshairs that I'm using here. Hold on, wait. I know they have annotate. All right. So, where is it? Okay. All right, so here's the thing. How you read the vernier caliper. First, to look at what the smallest division on the main scale is. So when you look at this one here, what's going on here?
Sir, I made a mistake. Is it 12.26?
No, it's not even 12.26, you know. Hold on, wait, 12.26. Yes, it'd actually be 12.26. But let me work it out for those who are not clear as to how you'd get the actual reading. It's just that, all right, this is not working as though I don't want it to. And then that, no. All right, good. So I got rid of that. What I'm trying to do, all right, you know what? Let me just use the mouse and done. So what is this? Okay. When you look at here, bear with me here because I'm trying to get this thing to annotate, draw. All right. And it's not highlighting. Anyway, yeah, so here's the thing. This one here, That's 12, that's 13. So that's 1 centimeter span up top. The divisions in between are 10. So that's 12.1, 0.2, 0.3, 4, 5, going all the way down to 13. So the first reading is on the main scale, and the vernier scale will start here. All right, the vernier scale starts here. So the first reading you'd have to record, and that's 12.2, because this is 12.0, then you have 12.1, then you have 12.2, and 12.3. So it is actually behind 12.2, but in front of 12.3. So the first reading is what it is behind, which is 12.2. All right. Then the second reading is taken from the vernier scale itself. The vernier scale is 10 divisions of the smallest on the main scale. So the smallest division on the main scale is 0.1 of a centimeter. So on the vernier scale, you divide that by 10, which is 0.01 of a centimeter. All right, so let me say that again. The vernier scale, for this vernier scale rather, if it has 10 marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the smallest reading on the main scale, the vernier scale divides that by 10. The smallest reading on this main scale is 0.1. Each of those small readings is 0.1 of a centimeter. So therefore the vernier scale divides that by 10. So each of them on the vernier scale is 0.01. So the first reading was 12.2. The second reading, to find it, you look at the mark on the vernier scale that lines up exactly with one on the main scale. All right. So the trick to the vernier, you have to find one mark on the vernier scale that lines up exactly with the one on the main scale. And the only one that lines up exactly on the vernier scale and main scale is the sixth reading on the vernier. So when you look here, 1, 2, 3, 4, 5, the sixth one, you see that lines up nicely with the one on the main scale, right? So that one is the one you're going to use on the vernier scale, not the main scale, on the vernier. So that is the sixth, and you multiply 6 by the reading on the vernier, which is 0.01, so that works out to be 0.06, and then that's the vernier reading, 0.06, and you add that to the main scale, which is 12.2, and then you get 12.26 as the overall reading. So that is how that would actually work out. And the answer there would, of course, be B. All right. So I hope that you're a little bit better in terms of reading the vernier scale as it relates to how to determine the measurement from a vernier caliper. So the answer there would be B. All right. Which of the following measures may be classified as scalar quantities? This you should know already.
A.
A. All right. A says 1 and 2 only, which is correct. All other answers, B, C, and D, has 3 in it, which is displacement, and displacement is a vector. So the answer there would have to be the one that has only time and speed, which is, of course, A. 10. Pressure in a liquid can be calculated using the formula. P, big P there is pressure. The symbol beside the equal sign, that's rho for the symbol for density. G is gravity, H is height. Which of the following sets of units will result in the SI unit of pressure?
D.
B. No, B would not be the correct answer.
D.
D as in what, dog?
Yes, sir.
Yes, D is correct. Remember, you must work with SI units of each quantity that is being combined to get the correct SI unit of the end product. So remember, all right, let me ask you, what is the SI unit of pressure?
Kilogram meter
Pascal.
squared.
Huh?
Kilogram meter squared.
Kilogram
Kilogram per
meters.
meter cube.
Oh,
Hold on. What is the SI unit, the accepted SI unit of pressure?
Pascal.
Yeah, it is named, the common name is Pascals, but what is the SI unit? What is
PA.
Pascal? Say again?
PA.
No, man. The symbol for Pascals is PA. And the common name for pressure units is Pascals. But the SI unit, all right, how do you calculate pressure? What is the general formula for calculating pressure?
Force over area.
Good. What is the unit of force?
Newtons.
What is the unit of area?
Meters cube.
No.
No, meters squared.
Meter
Sorry.
squared, good. So if you divide force by area to get pressure, then the units of air pressure would be force units over area units, which is what?
kilogram meters cube.
Newtons per meter cube.
Newtons per meter squared.
Squared. Thank you. Sorry.
Right. Now, in terms of the base units, because I hear somebody mentioning it, in terms of the base units, it would not be kilogram meters. I don't know what the person said, but if you want to work out the base units, we would actually work out to be kilogram per meter per second squared. All right, it's only a shame that I can't really write it out for you because the base units of force is kilogram meters per second squared, which is the Newton, which is at the top. And the area units, when you combine those two, you would end up with per meter, because meter over meter square gives per meter. And so that would be giving you kilogram per meter per second squared. But we're not talking about that. We're just talking about newtons here. All right. So we have established that the area units is Newton per meter squared. Now, based off that knowledge, you'd have to look at how the units now will combine with density, with gravity, and with height to give you Newton per meter squared. All right. So the answer there is D, but you need to confirm it by ensuring that the units that you work out, when they combine, and all three of them combine, you get Newton per meter squared. All right. And just for the interest of time, when you combine density kilogram per meters cube with Newton per kilogram, you would have the kilogram and the per kilogram canceling, so you end up with Newton per meters cubed. And then when you combine that Newton per meters cubed with meter, then you end up with Newton per meter squared. Are we all seeing the logic?
Yes, sir.
Good. So the answer there is D. All right. Let us continue up to 11. Item 11 refers to the following diagram. All right, read through that. I'm going to put my baby down to sleep. Give me a minute. Just read through that. I'll be back. Right, so first the following diagram, which shows two vectors of magnitudes A and B represented by OA and OB. And we see the diagram OA is vertically up and OB is horizontally to the right. Vectors act at a point O and are directed perpendicular to each other. Which of the following pairs represent both the magnitude and direction of their resultant? All right. So first of all, with vectors that are 90 degrees to each other, how do we find the resultant?
Pythagoras theorem.
Good. So with that knowledge, which of the responses here shows or reflects Pythagoras' theorem?
D.
All right, well, C and D both show it.
D.
C and D. But the question is it C or is it D? Now we go back to the diagram. The resultant, how would it point? They say it's either
From O to C.
from O to C. All right, so based on how it is set, we have vertically upwards, horizontally to the right, then the diagonal must point upwards and to the right. So that points from O straight to C. So the answer there is indeed D. Yes? Yes? The phone is what? It's too slowly. It's moving too slowly? Yes. Bring it to daddy. All right, number 12, the acceleration due to gravity is to be determined by measuring the time t taken for a small steel ball to fall through a specific height. Which of the following activities is unnecessary? We're finding the acceleration due to gravity is to be determined by measuring the time. It will soon come out. So which measurement or what consideration is unnecessary? Go. What did you do?
The mass of the ball.
The mass of the ball. All right. Allow the ball to drop and start the stopwatch. Measure the height through which it falls. Repeat the time measurements until the average. So yes, the mass of the ball would not be necessary. All right. Everything else is necessary to know. All right, because really and truly, when you're dealing with because it's a motion issue. When you're dealing with motion, you don't really need to consider forces acting, because if you're talking about mass, then you're talking about the forces that are present. When you're dealing with motion, then mass is not that necessary. 13. First to the following graph, which shows the displacement. Let me see if I can get this into full screen. So no, that doesn't work. All right, let me come back on full screen. Right. So item 13 refers to the following graph, which shows the displacement of a runner from a starting line, how it varies with time. I hope you're seeing this graph clearly. Let me zoom it a bit. All right, so that's the graph. All right, the lines are a bit blurry, but you have the 24, and that goes across horizontally and comes down to 100, and you have the 12 going across horizontally and coming down to 50. So this is a displacement time graph. All right, so the question is asked, from the graph it can be deducted that the runner is, so what would you say this graph is showing with regards to the runner? All right, let me zoom it, take the zoom off a bit so you can see both the graph and the responses. All right, so from the graph, it can be deducted that the runner is what's happening to the runner based off the displacement time graph.
Going at a steady speed.
All right, any other options? Well, we know it's not a case that the runner is not moving, because the displacement changes. And once the displacement is changing, then you're not stationary. But why is it that it's not going slow and slower or faster and faster? It's not just the CR is going at a steady speed, but why is it not a case where the runner isn't slowing down or is speeding up? Why is it that the graph doesn't show that? How can you know that the graph is not showing that?
Sir, because the gradient at the 2 points will be equal.
Oh, so you're saying that the gradient at all points will be equal. All right. Yeah, that's one way to reason it. But a simpler way, look at the changes of displacement with the changes of time. From 0 to 50, you cover 12. From 50 to 100, you cover 12 more. So what you find is that there are equal changes of distance with equal changes of time. And that gives no the indication that whatever speed that person is traveling at is a steady speed, because there are equal changes of distance with equal changes of time. All right, but yes, the gradient being the same at all points or displacement time graph does indicate a steady velocity or a steady speed. All right, so 14. Time period of a simple pendulum oscillating with a small amplitude depends on, everybody should know this by now. And the answer is
The length of the pendulum.
good.
C.
Lovely. Everybody should know that, and we don't need to explain why that is. You know from the graph, from the lab rather, simple pendulum, that length and period are directly proportional. An object is removed from the ground and placed on a shelf. Which of the object's properties is expected to increase? And this should be something that everybody should know. Say again?
The potential.
Potential energy.
Lovely. So we don't need to deliberate on that much. 16. First to the following diagrams are 4 vessels filled with water. Different shapes, different heights. The pressure due to the water is greatest at?
Q, sir.
Why Q?
Sir, because pressure increases with depth, and from looking at all 3 diagrams, you can see that Q has the lowest pressure. Not the lowest depth, rather.
Greatest depth. Or is the lowest point below the liquid surface? Yes, you are correct. All right. So even though they're on the same horizontal level, the level of the water in the containers are different, and for each point there are different depths, and Q has the greatest depth. Therefore the pressure, which of course fluid pressure is directly proportional to depth or height below a point, height above a point, all of that. So answer there is AQ. A bubble of gas rather, rises to the surface of a soft drink. This is because these are some little tricky questions that are sometimes sent, because they all sound correct, somewhat. But there's only one correct answer. And the correct answer is there. So lest you're thinking that, well, it's not there, it is. But I need somebody to tell me what the correct answer is. And we're learning here now, so.
Sir, is it C?
C. All right, upthrust on the bubble is greater than the weight of water it displaces. No. Because Archimedes' principle tells us that the upthrust on an object, whether partially or fully submerged, is equal to the weight of fluid that it displaces. In this case, the bubble creates the displacement, and the fluid is the water around it. So the upthrust on that bubble is actually equal to the weight of water it displaces. All right, it's not greater. So I'm telling you,
Sir, someone in the chat says B.
All right, somebody in the chat. Okay, as I said, it's very difficult for me to navigate this chat. B, D, C. Okay, that's recent. So the answer there is B. And yes, it is indeed B. Hold on, wait. All right. Where am I now? Good. Yes, the answer there is indeed B. The upthrust on the bubble is greater than the weight of the bubble. Because for you to have something to rise, the upward force must be greater than the downward force. The upward force is the upthrust, the downward force is the weight. The density of the gas is greater than the density of the drink. No, if that was the case, then it would sink because a more dense object sinks in a less dense. Or rather, a denser object will sink in a fluid than the density of the fluid itself. As in, I already said that C is incorrect. I don't know if somebody was trying to say something there. Are you breaking up if you're trying to respond? All right. So the answer there is B. Upthrust on the bubble is greater than the weight of the bubble. The weight of the water displaced is less than the weight of the bubble? No. All right. Because if that was the case, then the object would not rise. Because the weight of the water displaced is the upthrust, and if the upthrust is less, then it would actually sink. So 18, which of the following statements about the pressure law are true? There are three gas laws: Boyle's, pressure, and Charles. Which of the statements for the pressure law are true?
Sir, is it 1 and 3?
1 and 3. Actually not. No, it is not 1 and 3.
There is it 1 and 2?
1 and 2, sorry about that.
Yes, the answer is 1 and 2. The pressure law tells us that for a fixed mass of gas at constant volume, the temperature, absolute temperature, and the pressure are directly proportional, which means that the pressure will change as a result of a change in temp or vice versa. So we cannot have pressure being constant. Volume is, but not pressure. And of course, the part one to that, ratio of pressure to Kelvin temperature is a constant, yes, because when you change pressure, temperature will change correspondingly, such that whatever the pressure and temperature values are, you'll always get a constant when you divide the two. The ratio is division. So the answer there is A, 1 and 2. 19, which of the following statements concerning the radiation of heat is or are true? Radiation. We're looking at true statements here.
Radiate heat in the sub-3 in the material.
A, sir.
A, 3 only.
D.
Yes, sir.
D, 2 and 3 only. D is correct. Radiation can only take place in a material medium. No. Radiation gets to us from the sun through a perfect vacuum or a near perfect vacuum. So that's not true. A good absorber of radiation is also a good emitter. That's a rule. Dark, dull surfaces are better emitters than shiny ones. Yes, because a black body is a perfect emitter and therefore a perfect absorber. So 2 and 3 are the correct statements. That would give us D. 20. An electric kettle full of water is plugged into the mains. Same thing that you plug the socket in the wall. The process by which heat travels through the water is known as?
Convection.
Convection.
Convection, correct. 21. Energy required to change the state of a substance was determined to be EH. This is a repeat question. The mass of the substance is double. The value of EH will?
Oh.
Double. Be double.
I don't know if you're sure when you're saying double. You sure?
Double.
All right. Yes, it would be double. Because yes, it would be double. Yes. The energy required is dependent on the mass and on the latent heat value. The latent heat value is a constant, so therefore energy and mass are directly proportional. So if EH is corresponding to a certain value of mass, if you double that mass, then EH will naturally need to be doubled to achieve the same thing. So 21 is B. 22, so the following statements about evaporation is false. So one false statement is here about evaporation.
There, it's blurry again.
Blurry, sir.
Say again?
The paper is blurry now.
Oh, it's blurry again. All right, let me stop the share and then restart. Last time that fixed the issue. Is it better now?
No, sir.
Still poor.
Yes, sir.
All right. I don't know. It seems to be on my end. I don't know what's happening here. How about now? Is it better? Yes, no, yes, no. Talk to me.
No, sir.
No, sir.
Okay. All right. This is a new one. All right. Are you able to see my video feed properly?
Yes, sir.
Okay, so you're seeing me. All right. Okay, let's see. Hmm. How about now?
Perfect.
It's better now, sir.
How is it now?
Better.
It's better.
Oh, I ticked a thing about optimizing. Yeah, man. Something that I ticked while I was going on to the screen sharing that I unticked and I realized that, you know, it fixed it. All right, so we move on. Right, so a false statement for evaporation, A, B, C, D. Which one is false?
It's false.
Second, A?
Yes, sir.
All right, let's look at A. Evaporation occurs at room temperature only. Yes, that is false. It occurs at any temp. Evaporation requires heat energy and causes cooling. That is true. Evaporation occurs only at the surface. That is true. In evaporation, faster moving molecules escape the liquid. So those three are true, is false. So molten naphthalene, and just by way of information, naphthalene is the same thing when they call camphor ball, those white spherical things that you sometimes throw in areas where you have clothes to get things out. Yeah, right. So naphthalene is at 100 degrees Celsius and allowed to cool to room temp. If the naphthalene has a melting point of 80 degrees Celsius,
Right now.
which of the following graphs best represents the cooling curve for naphthalene? Let me just probably have to zoom even more so you can see all the graphs at the same time. So we're looking at the cooling curve that best represents naphthalene, and its melting point is 80 degrees. Right. So which of the graphs here indicates the cooling curve for naphthalene?
B.
C, sir.
Say again?
C.
C as in boy?
C as in C.
Cat. All right. Yes, C indicates that it won't be A because, all right, let me just tell you why it's not A, B, or D. Once you have something cooling and then it hits the melting point, or it hits the freezing point, melting and freezing are just opposites of each other. But even if you have something cooling from a gas to a liquid and it hits the boiling point or the condensation point, you must have a section of the graph showing a constant temp. All right. A, B, or D does not show any constant temp point. It shows a change, yes, but it does not show the temperature remaining constant over time. So C alone indicates that, so therefore the answer is indeed C. All right, let me just bring this back up in terms of the zoom. All right. The specific latent heat of vaporization of water is the energy required to change 1 kilogram of water at, this is a repeat question. So the
C,
specific
sir.
latent heat of vaporization of water, C, all right, is energy required to change 1 kilogram of water at that to steam at that, right? So as I was saying earlier on about phase changes, you must have a constant temp situation, all right? The temperature must be the same at the start, throughout the end, to the end of the process. And the only one that shows that is both A and C, but A mentions ice, and vaporization does not deal with ice, it deals with gas, vapor, steam, that type of thing, all right? 25, a metal of mass M requires energy E to raise its temperature from T1 to T2. The specific capacity of the metal will be given by, all right, that's something in the chat.
C as in dog.
Say again, D as in dog?
Yes, sir.
Yes, D would be correct, all right? Let me see, hold on. Raise the temperature from T1 to T2. All right, here's the thing now. Raise the temperature from T1 to T2. So the change, okay, good, right. So D is correct. Here's the thing, I was a bit thrown off by C response because C is very close. But the difference between C and D is that C looks at subtracting T2 from T1, whereas D looks at subtracting T1 from T2. So really and truly, when you read back the question, it says its temperature was raised from T1 to T2. That means that the initial temperature is T1 and the final temperature is T2. To find the change of temperature, it is always subtracting
from the
initial from final. So it's final minus initial. So it's be T2 minus T1 and not T1 minus T2. So you have to watch out for that as well. All right, because C and D, the CXC sometimes likes to send curveball in terms of multiple choices. They look very close, very close. We have to pick the correct one, and the correct one would be D. Because to find the change of temperature, you'd have to take T1 from T2. So it's T2 minus T1. And of course, the equation is E is equal to MC delta T. Delta T is the change of temp. And when you transpose for C, small c, specific capacity, you would have E over M delta T. And in this case, delta T would be T2 minus T1. All right, good. 26, when heating a substance, a point is reached where there are no further changes in temperature is of the, let me say that again. When heating a substance, a point is reached where no further change in temperature is observed. The most likely reason for this is
B.
B, substance is changing state. The only reason why temperature will not change for a substance that is heated is because it is changing state. Else, it is just simply getting hotter and hotter. All right, we're on to 27. Which of the following phenomena are exhibited by sound waves?
Interference, diffraction. 2 and 3.
C.
C, 2 and 3 only. Any other option?
Yes,
Any other choice?
D.
D, refraction, diffraction, interference. So why did you say D? Why is it all three?
Sure, because sound wave can
perform all of those qualities.
Are you sure?
Yes, sir.
All right. Just want to make sure that you're sure. But my question is this. What is missing from that listing?
Reflection.
Good. Just wanted to make sure you're sure. All waves, no matter if electromagnetic, longitudinal, mechanical, transverse, it no matter. All waves are able to exhibit reflection, refraction, diffraction, interference. All right,
Okay.
4 of them. So it is all 3 that they are able to do. Sound waves can be refracted, sound waves can be diffracted, and sound waves can interfere. Are there waves? 28. Whenever there is a complete destructive interference between 2 coherent wave trains or wave sources, the waves must be
A. In phase.
B
A
as
is
in
not correct. No.
Yeah, B.
B as in boy, out of phase by half a wavelength. Yes.
That's what I would
Yes, this
say.
is true.
Mhm.
Yeah. The thing about it is that for you to have complete destructive, all right, we must talk about interference. Interference is when the waves mix, they're the same frequency and more than likely are coming from the same source. Don't necessarily have to be, but if they are not coming from the same sources, then they must be coherent. Coherent means that they have the same frequency and, well, they don't have to have the same amplitude, but they have the same frequency. All right. Now, when they have the same frequency, they either completely, well, they interfere either completely constructive or completely destructive or in between. Now, complete constructive interference is when they're completely in phase. They do the same thing at the same time, they're mixing properly, and they just reinforce each other. All right, so they build up each other and they add to each other, and then you get to a stronger overall single wave. When they are completely destructive, they mix, but they must so be arranged with each other so as one cancels out the other. Now, if you recall about how waves operate in terms of transverse, you know you have crest and trough. And a crest with a trough gives you a complete wavelength. If you have 2 waves coming in and they are shifted by half a wavelength, it means that one wave, when it's going crest, that wave, the other wave is going to trough. And when that wave, that first wave is going to the trough, the second wave is going to the crest. That now causes complete cancellation or complete destructive interference. So when they're out of phase by half a wavelength, then they, therefore, when they mix, they cancel each other out. It's not by one wavelength, because shifting it by one wavelength does means that one is ahead of the other by a full wavelength, but they're still in phase. But it's just that one is leading the other, or one is lagging behind another, but they're still in phase. All right. So A and C is essentially the same thing. D, quarter of a wavelength out of phase, it means that there will be a portion of the crest that the trough of the second wave will not be able to fully cancel out. So for you to have complete destructive interference, then you must have it that crest and trough are meeting to cancel each other, and that only is achieved by when they are shifted by half a wavelength. Clear? Good. All right, 29. 29 refers to the following graphs which act with axes having the same scale of 2 sound waves P and Q. I'm going to have to zoom this out a bit so you can see it. All right, good. So P and Q, same time scale. That's what they said, right? Same, having the same scale. Oh, yes, having the same scale. But P is there and Q is there. Which of this following statement is true? All right. So we're looking at what the statements are saying and which one is true. And I assume that only one should be true. So question is P louder than Q but has a higher pitch? We're gonna have to go through all 4 of them to make sense of it. So the first one is P louder than Q? That's the first question.
Yes, sir.
Yeah.
How do you know that P is louder than Q?
P is not louder than.
All right, how do you know that P is not louder than Q?
Sure, because Q has a higher amplitude than P.
Excellent. That's what I want to hear. Once you look at the wave and the wave has a greater amplitude, then it has a louder sound, it has more energy. So A is out, good. P is louder than Q, no, so B is out.
Yeah.
Q is louder than P, so it's either C or D. All right, because both C and D deals with louder than P. Good. So the next question is, does P, we're looking at C now, P has a higher pitch.
Yes.
Yeah.
Yes, sir.
How do you know that P has a higher pitch?
Because of the number of wavelengths in the period.
Okay. So what, all right. What is the wave property that pitch is linked to?
Frequency.
The? I heard it. Just say it.
Frequency.
Frequency, good. So pitch is linked to frequency. Higher pitch means higher or lower frequency. That's a question. A higher pitch means that the wave has a higher or lower frequency.
Higher pitch will mean, all right.
So these are the things we have to be sure about. All right. I know that you know frequency and pitch are linked, but how is it linked? Is it a case that a higher frequency means a higher pitch or a lower frequency means a higher pitch? Which is it?
So the greater the frequency, greater the pitch or something.
All right, so greater frequency, greater pitch. Good. Now, you made mention about the greater number of waves being there. Yes, there are more waves within a certain time period. So that means that the period of the wave is what? Greater? Because we have to reason this out, you know. More wave cycles within that time period means that the period is greater or lesser. Probably I'm not asking the question properly. Because of P, within the CI, if you look at the time period for P and for Q, you realize that yes, clearly there are more wave cycles for P within a certain time. So for one wave cycle of P and Q, is it a greater time or a shorter time for one wave cycle? When you look at Q one wave cycle and P one wave cycle,
P
would
takes
P
a short
have a
amount of
great
time.
P is shorter.
P is shorter, so P has a smaller period.
P
and
almost
how a
looks
period,
half a one. One for P almost looks like half.
Exactly.
Okay.
So what we have now is like a 1 to 2 thing, right?
Yeah.
Whatever
Yes,
the period for P is like double for Q. But the essence is that P has a small period. Now what's the link between period and frequency?
The shorter the period,
right?
The higher the frequency.
Good. So you see how everything comes out now? The P wave has a shorter period. That means that the frequency is higher. And if the frequency is higher, that means its pitch is higher. All right? So therefore, that is why the answer there is C. All right? These things can be reasoned out, but as I said, you must allow yourself to reason these things out. All right? All right, this should be no problem. Which of the following expressions expresses, let me just zoom this up for those who may have a difficulty. Which of the following equations rather, expresses a correct relationship between the wavelength, wave speed, and frequency?
B.
Say again?
B as in bat.
No, B is not correct.
Is it A?
A is correct. What is the equation for wave speed, frequency, and wavelength? V is equal to what? V is equal to F lambda, right? Good. So once you know that, then it's just a simple matter of transposing correctly as to what would give you F or lambda. So when you transpose for F, you would end up with lambda dividing speed. All right. And if you transpose for lambda, it's the same thing. You'd end up with V divided by F. So the only one there that is correctly arranged is A.
Yes,
all right. Okay, we're over to number 30. What is it? 31.
31.
The 31 refers to the following diagram, which shows an object in front of a plane mirror. I'm gonna have to zoom this out. Right. So this is the object. The object is here. The plane mirror is to the right of it. Which of the following options best represent the image produced by the plane mirror of that object?
Not seeing all the
I have to
answers.
probably zoom it out even more. Yeah, I know.
B,
I
sir.
have to zoom it even slightly more. Let me just bring it up. B? Did somebody say B?
B, sir, yes.
B. All right, the answer there is indeed B. Remember, for objects that are in a mirror reflection, the image is inverted or left and right, or mirror images, as they'd always say. But the best way to look at it is to look at the object distances. All right, let me just zoom this up a bit so I can explain. When you look at the point of the arrowhead to the mirror, you just Esther, be quiet, please. You have to trace now from the mirror line to the right the same distance, because remember, object and image distances are the same. So when you trace from the arrowhead to the mirror, and then from the mirror line to the right, that distance will be the same. And when you trace from the other end of it to the mirror, and then from the mirror to it, you will see that B now would end up with the arrowhead being closer to the mirror, right? But on the same, in the same orientation, which is up, because A shows it down, so that's out. C shows it down, that's out. D shows it up. But the issue with D is that the object distance and the image distances are not the same. Because when you look at the arrowhead in the object, you see that it is closest to the mirror. For D, it is furthest from the mirror. And when you look at the arrow tail, it is furthest from the mirror. And when you look at D, it is closest to the mirror. So the only one there that shows how it should be is B.
So it's kind of going to be the opposite. Say again? Is it kind of going to be the opposite?
Yeah, in essence. Yeah, they call it mirror images, or it's inverted, but pretty much what you have is just like your hand, because your body is like you have a mirror line going down the middle. All right. When you put a perfectly vertical line along the how would I put it now? I don't know what the biologists would call it, but pretty much when you draw a line, a vertical line from the top of your head down, straight down to your feet, and it cuts the body completely in half, then essentially that serves as a mirror line for your body. So that's why when you talk about left being right and right being left for your body, that's the best way to explain how a mirror shows it. All right. So whatever is on one side, you'd see it completely inverted on the other side. All right. So the thumb, so if it's in the middle, right, the thumb distance and this distance are the same. The fingers are the same. You understand? So everything now is basically flipped. It's inverted. All right. Right. So that's how it goes for mirror images. All right. We're on the 32, is it? Right, good. Following diagram shows, all right, it refers to the following diagram. Which line lies along the principal axis of the converging lens? I'm gonna have to zoom this a bit. Right. So which line lies along the principal axis of the converging lens? Is it JK? Where's JK? J to K. Is it PQ? Is it RS? Or is it WY?
RS, sir.
RS? No, it would not be RS. First, remember now, you know, we have to identify where the lens itself is, which is that shape there with the biconvex thing taking place there. And then we have to know what the principal axis is. All right. The principal axis is that line. Say again?
Q.
PQ? No, that's actually the principal plane. Principal axis.
JK would be the principal axis.
JK would be the principal axis. All right. The principal axis is that line that passes through the focal points and the optical center. The optical center of the lens is right in the middle of it. Focal points are F on either side. So that line that passes straight through the optical center and the focal points would be your principal axis. PQ is the principal plane. All right, it's a vertical line that passes through the optical center. But the principal axis is the horizontal line. And it has to be a horizontal line. Well, it depends on how the lens is. But typically that's how it is drawn. All right, so that is for 32. 33 is on this side. All right, so I have to zoom this out even more. All right, wow. All right, so it says, which of the following diagrams illustrate the law of reflection? Are you seeing all that? Or no, you're not. I'm gonna have to bring it down even more. Good. All right. So which of the following diagrams illustrates the law of reflection? Is it A, B, C, D?
C.
C?
sir.
A.
Yes, sir.
All right. It is A. It is A. All right. The problem with C, there are certain issues with C. The first issue with C is how they measure the angles. All right, let me just zoom it up so you can see what I'm talking about. When you look at C, the angle measured from the mirror line. All right. Hold on, wait. Let me just ensure where the mirror, right. Oh, yeah. There are so many things wrong. All right, first of all, the line that has the little thing sticking off at the back, that's where the mirror is. Because I wanted to know where the mirror line is. So the first thing is that the mirror line is at the wrong place. All right, normally it's horizontal, not vertical. Can be vertical, but usually it is horizontal. So even if it were vertical, reflection means that the wave does not pass through the mirror. It's reflected from it. So the mirror line being vertical here, and the waves, the lines now, the arrows passing from in both cases. One has to be pointing towards and one pointing away. All right?
So,
You
sir,
can't have both of them pointing. Yes.
as a result of the mirror, the mirror, it automatically cancel out C and D then.
Yeah, man, C and D would be out. But as I'm saying, you can have the mirrors being vertically arranged, but you cannot have the rays passing from one side of the mirror to the other.
Okay.
You understand?
Yes, sir.
Right. And both C and D shows that transitioning from one side of the mirror to the other side where the jagged pieces are, because the little short extensions mean that's the back of the mirror.
Yes, sir.
And the back of the mirror is really the reflective part. And the front of the mirror is the face of it, where the part, that's where the rays approach the mirror and leave the mirror. All right, so C and D are out. Now looking at A and B, the answer is A, but looking at B, how the arrows are, no, because the law of reflection states that the angle of incidence and angle of reflection are the same.
Equal. Yes, sir.
B would want to show as if the angles are equal, but remember the angles must be measured from the normal, which is that imaginary
Imaginary
90-degree
line.
line to the mirror line. You
Yes, sir.
understand what I'm saying? So, right. So the only correct thing there is A. Angles measured from the normal, angles are equal, the mirror line horizontal, the normal is vertical, the ray enters, hits the mirror, and reflects from the mirror. All right, so that's the correct thing there. We're at 34. Which of the following types of electromagnetic radiation causes tanning?
Ultraviolet.
Ultraviolet.
Ultraviolet. Good. Infrared only causes your skin to feel warm. It doesn't tan it. X-rays will just literally destroy it. But well, it won't destroy it in terms of visible destruction. It will destroy it on the cellular level, because once your body is exposed to X-rays, it causes cellular mutation and all of that. So, and light, of course, is what we're exposed to on a daily basis. So that doesn't cause us to tan. All right. But can I tell you that it seems as if the light is now causing persons to become even lighter, because I don't know what's happening with these persons' complexion nowadays. You probably have to explain it to me. Probably at the light, something like the light. I don't know, but yeah, only tanning is achieved through ultraviolet exposure, and that's typically what the Caucasians come to Jamaica for when they say they're getting a tan. They can get an artificial tan by lining a machine that gives ultraviolet rays, but the best thing is the sunlight. Moving on, 35. A ray of white light enters a transparent glass prism. In which of the following diagrams is the dispersion of light correctly illustrated? I'm going to have to zoom this out a bit. Right, so we're looking at white light entering a prism, and then we're looking at what will exit. All right, two of these responses are close, and
Yes,
one
sir.
being correct. Two. All right, so you have A, B, and the answer that you have chosen. Why did you choose A?
Looking at it from the way the
Yes.
image and the light scheme, in a sense, you automatically strike out C and D because
Good.
this.
So C and D, you said, or B and D?
Uh,
Because if you look at A and you look at C, they're very close. So I
yes, sir.
wouldn't strike out C right now. I would strike out B and D. Why? Because once the ray enters from the left side, then there will be some level of refraction and some level of splitting, because the splitting will start to take place the minute it enters the prism. When it exits the prism, then more separation will take place. So looking at D, D shows as if it is passing through unaffected until it reaches the other end, and then it just separates out.
Yes,
No.
sir.
B shows that it refracts somewhat, but it is still traveling together as the combination of all colors, which is also a no. So
Yes, sir.
A and C shows that it hits, it separates a bit, and then it hits again on the other side, and then it separates even more. The issue with A and C is that, and you can see it, because you should know the component colors already. Roy G. Biv.
Biv.
Right. But the issue with it is that it shows that one side of the spectrum is bent slightly, or one side of the spectrum is bent more than the other, of which it will occur that way.
Yes, sir.
Of the 7 component colors, the spectrum, there will be one side of the spectrum that will be refracted most, and then the other end would be refracted the least.
Yes, sir.
Question is, which is it? Is it a case that the violet section will bend most and then the red section bends the least, or is it a case that the red section bends the most and then the violet section bends the least? That's the question.
So I would say the red section bends the most.
All right, I'm gonna ask you why. All right, let me just help you out and tell you say yes, but why? All right, let me even help you even further. What is the difference between red light, orange light, yellow light, green light, blue light, indigo light, violet? Yes?
Sir, is it because of the wavelength?
Lovely. Wavelength. That's the issue. Yes, Esther Marie. Coming. Give me a minute. Right. Red has the longest wavelength. Violet has the shortest wavelength.
Yes, sir.
Having the longest wavelength, it means that it will be bent more because it slows down more.
Yes, sir.
Having the shortest wavelength means it is bent less because it will be slowed down less.
Yes, sir.
All right. So because it will be bent more, the red portion is at the lowest point. The violet portion is at the uppermost point. All right. As again I said, when the opportunity arises, CXC will send curveball and they will test if you know what you claim to say you know. So A and C are very close. They should be the exact same drawing, but in terms of the arrangement of the colors, that's where now they would find out if you know what you say you know. So real and truly, the one with the shortest wavelength will be bent least because it will slow down the least, because you know that short wavelength has high frequency. A high frequency is not easy to stop as it is for low frequency. Low frequency easily slows down. Long wavelength easily slows down. So red would be bent the most, deviated the most because of its longer wavelength, and violet would be deviated the least because of its shorter wavelength. All right, which best diagram best shows the path taken through a ray of light through a rectangular block? These you should already
So what's the
know.
answer for 35?
35? The answer
Yes.
is C.
Okay.
The answer is actually C. All right, if we weren't clear. Workout 36, give me a minute. Yes, sir. Here's the juice. When you finish, come for it here. Okay? Don't carry it on the bed because you want to get it. Right, so answer for 36 is what? Say again?
I would say B.
You would say what? I didn't hear you.
Explain it. You explain it.
I don't know if you're talking to me or talking with yourselves. I'm not sure.
Now I'm saying you explain it.
Oh, all right. Similar to what we did with the prism. Let me see. There's a section in the chat that someone is responding. C. Is that recent? Yes. All right. I see somebody here saying C. C is the correct answer. The reason for that, when you look at A here, yes, when it transitions from here, because this is a glass block, so it's coming from here to the glass block and back to here. From the ear to the glass block, less dense to more dense, it bends toward the normal. Let me zoom it so you see what's going on. So when it goes from here to here, yes, it bends towards the normal, but coming from here, it's like it's somewhat reflected here or bent so strongly. No, that's off. All right, so that can't be A.
Yes, sir.
B shows it passing through unaffected. So that's a straight line. So once you see that, you know that's incorrect because it has to be bent.
Yes,
D shows it bending towards the normal and then away from the normal, of which that should happen. But the issue is that whatever extent it was bent going in, it will be bent the exact opposite coming out.
Okay, sir.
All you'll have is that it will come out when it emerges, it will come out along the same general direction, but it will be shifted slightly away.
Okay.
We call it laterally displaced. So when
Yes,
you
sir.
trace the line for C, if you trace a straight line where it enters through the block and you look at where it comes now out of the block, those lines will be parallel, but
Yes,
it will be shifted away from its direction. So the answer there is actually C. All right. Whatever it was bent going in, it will be bent the opposite way coming out. So it's just shifted. It's not changed. The direction is not really changed per se. Yeah, the direction will be different simply because it has been shifted, but the directions of the entering wave and the exiting wave will be parallel, but just shifted. So where are we? We are at now, I was at 36, we're now at 37. A ray of light leaves the air and enters glass of refractive index 1.5. The angle of incidence is 37. What is the sign of the angle of refraction? This looks like a repeat. It's similar, it's close. I don't know if it was repeated, but I've seen this before. So what is the sign of the angle of refraction? Well, that's 37 we're looking at there. All right, question is, how do refractive index, sign of incidence, and sign of refraction all relate? What's the equation for it?
Sine I over sine R equal refractive index.
Good. Now, the refractive index they say is 1.5. Angle of incidence is 37. So that's a sine of 37 over the sine of the angle of refraction. Now, when you transpose for the sine of the angle of refraction, what do you end up with?
D.
Say again?
B.
B.
D.
No, D.
D.
Oh, D as in dog. Yes, you'd end up with D because the sine of the refraction would go over and multiply by the refractive index. And then the refractive index would come over and divide. So it will basically take the place of sine of the refractive index. The sine of the refracted angle, sine of refraction. So the refractive index value would take the place of sine R, which is sine 37 over 1.5. All right.
So what would you be trying to get for C?
Say again?
What would you be trying to get for C?
That would actually find the inverse of sine of refraction.
Okay.
Yeah, man, because if D is the correct answer, D is the inverse of C.
Yes, sir.
So if D is the sine of the refraction, then C is actually the inverse of the sine of the refraction.
All right.
All right. 38 refers to the following diagram. Two similar loudspeakers are connected to the same audio frequency generator and set up as shown. So the audio frequency generator is here. You're connected to loudspeakers. The distance between the loudspeakers are 0.5 meters. And X and Y are a few meters, as they say. All right, so at some points along X and Y, no sound is heard because why would no sound be heard as you move along X to Y?
C, sir.
C, interference of the sound waves take place. All right. So the only, because remember, the four wave phenomena that all waves display, A talks about diffraction, B talks about refraction, C talks about interference, and D talks about reflection. But of the four, only one would affect the sound being heard. Well, diffraction will affect it as well, but only one would cause no sound to be heard. When you reflect, it's just bouncing off. When you refract, it's just changing direction. When you diffract, you just simply change the wave profile. So if it is longitudinal, then it may come out spherical. Only interference would affect the sound intensity or the sound being heard. And when you interfere, you either interfere to get a stronger sound or you interfere to get a weaker or no sound. All right, so the answer there is indeed C. 39. The human ear is incapable of hearing a silent dog whistle. Why? And this may be a trivia for some persons, but why is it that dog whistles can only be heard by the dog?
Sir, because of the range of frequency or something
Okay.
like that.
So my question is it higher or lower than the range of frequencies?
Higher.
Higher, good. And I'm going to pry a bit. What is the range of frequencies for human hearing? If you don't know, just say you don't know. I'll just tell you, but I'm just asking if you do.
Don't know, sir.
Okay.
Don't
All right.
remember.
This is something that you all should know. And you can write it down. The range of frequencies that the human ear can detect is 20 hertz to 20,000 hertz or 20 kilohertz. All right. For biology, you may have encountered this when you were doing the biology of hearing. All right. But yes, 20 hertz to 20,000 hertz is what the human ear can hear within. Anything below can't pick up on, anything above, it should not be able to detect. The dog whistle emits a sound above that 20,000 hertz, and that is why only dogs can hear it. So it's not A, it doesn't make a sound. It's not B, the speed of sound is too fast, because the speed of sound is the speed of sound. The only thing that affects is like density or the material medium it travels in. The frequency of waves are above the range, yes. Waves are infrared, infrasound, with frequencies below that detectable, no. All right. Infrasound is below, ultrasound is above. All right. So the frequency of waves are above the range that the human ear can detect. All right. So that's why dog whistles should be able to be heard alone by dogs. And I think it's like in the 100,000 hertz range. I'm not sure. You can Google it, but it's above it. That's why you're not able to detect it. All right. Which of the following EM waves has the shortest wavelength? Is it gamma rays, infrared, radio waves, ultraviolet?
Radio waves of the longest.
All right, check the chat. Somebody's responding. A. All right, the person who said A is correct. Gamma rays are at the end, the higher end of the EM spectrum. And by higher, we mean shortest wavelength, highest frequency, right? So the only one there that has the shortest wavelength or highest frequency is gamma rays. All right, so that's something that you should know. Which of the following, where are we? Oh, so the August is between 23 to 54 kilohertz. Thank you for that information. Right. Which of the following diagrams show the magnetic field formed between a bar magnet and a piece of iron? And this is a curveball question. All right. B, somebody said. C, somebody said. All right. B is not correct. C is correct. But here's the curveball. A shows the same arrangement for the magnet as this is for C, shows the iron as it is for C being in the position, and shows the same pattern for field lines. The difference between A and C is how the arrows point.
Yes, sir.
And you should know that arrows point inwards towards the north, the South Pole, and outwards from the north. So for A, it shows the arrows pointing outward from south, of which that is not correct. So the answer there is indeed C, because C shows the correct arrangement of the field lines and the arrows. So Renee, Blake, you are correct. All right, we move on now to 42. Which of the following current time graphs best represents a DC current? Let me just zoom this out so we can see all graphs at the same time. So we're looking at current time, and we're looking at the graphs that are shown, and all graphs are shown there. So which of the four shows DC current for, all right, let me see what Daniel says. D. All right, let's look at D. No, Daniel, so sorry. That is not a DC current profile. Any other person would like to try?
A.
All right, I hear somebody saying A. All right, who was that? Chantel Allen, was it? All right, so Chantel, A is correct. Let's see. What's the question? The question is the following graphs show current time, and they're asking now which best represents a direct current or DC current. All right, now here's the thing. None of them shows constant current. All right. Yes, that's that. All right, you can go to the bathroom, sweetie. All right, give me a minute, please. Right, as I was saying, all of them show direct current, but direct current is unidirectional, goes in one direction. When you look at B, B shows that you have one direction and then you have another. So the vertical axis shows direction and magnitude, but also direction. So when it's at the vertical up, that's one direction, vertically down, that's another. So B shows it constant, and then it instantaneously switches direction, and then it's constant, and then instantaneously switches back to the original direction. So it's going one way, then it switches to another, and then goes the other way. Go back the same way it was going. C shows it building constantly, and then it shows that it peaks in the opposite direction, and then it falls, and then it builds. And then C, well, that just shows an AC signal. So the only one there that shows unidirection, one direction flow, even though it's pulsing. All right, the current here is pulsing. It's building and falling, but it's still just going one way. So that is the real thing that you need to look out for when you're dealing with direct current. It has to go one way. It doesn't matter if it's steady or not. It has to go only one way. All right. 43. Which of the following circuit arrangements is best suited for measuring a lamp's voltage? I may have to zoom this a bit so you can see the circuits properly. What did I just do? Oh, 780. All right, 80. Good. I think I could bring it up a bit more. Let me try 100. All right, good. So we're looking at the circuit that best shows best arrangement for measuring the lamp's voltage. All right, you want to find circuit best suited for measuring a lamp's voltage, right? So we need to know the circuit symbols, and we need to know how the voltmeter must be arranged with the lamp to get the reading for the lamp. All right. So are we familiar with voltage? Not voltage, circuit symbols.
Yes, sir.
All right.
Yes,
So
sir. Somewhat.
somewhat. All right. Somewhat. All right. I see somebody saying C. All right. Let me just say yes. C is correct, but let me explain why. For A, we know that the section here, let me just zoom it clearly so we all can see. All right, so for A, the section here is the power supply or the cell, and that's the plus side and that's the minus side here. This is the lamp itself, as a lamp symbol there. This is the switch, that's a resistor, that's a voltmeter. So there's a power supply, the lamp, the switch, a resistor, and a voltmeter shown in all four, right? All four show this. Now, the first thing you need to know about voltmeters is that they must be connected in parallel. So A would be automatically out because that's in series. It's in line with how the current is flowing from plus going around to the minus. It doesn't matter if the switch is open or not. The voltmeter is in line with the current flow. That's incorrect. So that omits A automatically. Now, when you look at B, C, and D, yes, B, C, and D shows the voltmeter connected in parallel. It provides a secondary pathway or a second pathway for current to flow. Now, the issue with B is that the voltmeter is connected across the power supply. We need to find the voltage for the lamp. So we have to connect it across the lamp itself. So B is not correct because B shows the voltmeter connected across the power supply. D shows it connected across the lamp, but it is also connected across the resistor. So the voltage is measuring, the voltage being measured measures the voltage across the lamp and the resistor together. We don't need to find the voltage across the resistor. We're only concerned with the voltage across the lamp. So that is why the answer there is C. The voltmeter is connected across the lamp and the lamp alone. It is not connected across the resistor. It's not connected across the power supply. And we don't need to connect it across the switch. All right, so the answer there is C. All right, so for, who was it? For Daniel, yes, you are indeed correct. So that's Daniel Bonick. All right, we move on to 45. I'm gonna have to zoom this out a bit. Right, 45. Which which of the following circuit best, which of the following circuit diagrams best represents a series arrangement? And all four are shown. All right, let me check the chat. And Daniel says D. Not this time, Daniel. Hold on, let me see. Hold on. Let me check it properly. Oh gosh, this mouse is not working. All right. Shantae Allen says B. And I believe B to be correct. Alt H. Okay, good. All right. So Shantae Allen says B is correct. The issues with C, D, and A are that C and D have parallel arrangements. When you look at A, and you have to check it from the power source. All right. Yeah, I'm going to explain why it is B and not A, C, or D. When you look at the power source, current from the power coming from the current coming from the power source, when it goes to this point, it can go up and down. The mere fact that the current can find more than one pathways to get to the loads or the resistors, it means that automatically it's not a series. All right, so when you look at C, yes, the current comes and passes through the first resistor, but the minute it hits here, it can go up and it can go down. So that's parallel. When you look at D, when it goes to the left and it comes down, it can go to the first one, then it goes down even more to the second one, and goes down and goes to the third. So once you provide multiple pathways for the current to flow through the loads, then you automatically know then it is not a series circuit. So even though them kind of draw the arrangement in B looking like it's parallel, it's not. Because when you look at the pathway, it goes up, then it goes to the right, then it goes down, then it goes to the left through the first, continues in on the same path, goes down, then through the second one, then it goes. So it's one continuous line that the current is going through, and it comes back to the power source. All right, so you have to just follow the line. And once you don't have a multiple pathway or a break, well, not really a break, but once you don't have multiple pathways, then you know it is indeed series. All right. 46. First to the following diagram. So we have a 12-volt DC supply. The current will be heading down, across, and up through ABC resistors, and then it's through a bulb, and they say that the bulb has a 4-volt across it. All right. So it says, given that the potential difference across the lamp in the circuit is 4 volts, what is the potential difference across resistors? A. All right. Now, the first thing you need to know is how do we find the, all right, before we get to that, let me ask you, what would you suggest? As in an answer. Is it A, B, C, or D? All right. Hold on, wait. Here and there. All right, let me go back to the screen sharing. Right. So somebody had, all right, so Daniel says A. All right, Daniel, it is not A. Anybody else wants to make an attempt at this? All right, nobody wants to attempt. All right, okay. I see somebody else making an attempt here. No, it's not D either.
Is it C?
All right. I said it's not A, it's not D. You say C. I'm gonna ask you why C.
Just asking, sir.
All right, here's the thing. First thing you should know is that the voltage across a parallel section, this entire section here, will be the same. So whatever voltage is across A, it will be the same across B, and it'll be the same across C, because you'll be measuring it from one junction point to the other. Let's see if this works. Good. So from this junction point across to this one, voltages will be the same. All right, I'm getting a lot of feedback from, I'm not sure who that is. Would somebody mute that person, mute their mic, please? I don't know who it is. All right, hold on. Let me see if I can find out who that is.
Sir.
Come in, come in. All right, I believe that everybody's muted now. Hold on. Who am I getting feedback from? Somebody's. All right, good. Right, so can get back to it. No. Good. Right. So as I was saying, the voltage across this point to that point would be the same for A, B, and C. The issue is that what happens when it reaches out here? Now, once you have things that are in series, they share the voltage, all right? So this has 4 volts across it. The supply is 12. So the issue is that if this takes 4 and there's 12 supply, then the balance goes across all of this. So to find out the voltage across all of this is we have to take the 4 volts from the 12 volts. And then if they're asking, right, if they're asking about resistor A, it's simply whatever is across the entire thing, because A will have the same voltage that B will have and the same voltage that C will have. So the answer there is C, 12 minus 4 of the volts, all right, which will be 8. All right, but you must be aware that the voltage across A, B, and C are the same. So when they ask about A, they're really asking about the entire thing. All right?
Sure.
Right. Remember when I was telling you, for those who were here the last session about logic gates, knowing the gates, right? So I don't know if you had taken my advice, but yeah. They're asking you know about the symbol for the NAND gate. So what's the symbol for the NAND gate?
D.
All right, I see somebody responding here. B?
Yes, sir.
Is that B for boy?
No, D for dog.
D for dog. All right, let me see what the chat says. D. Okay, so we all agree that it is D. What is A? What's the symbol for A?
Inverter gate.
All right, which is the
Or gate.
not gate, right?
No, not.
Right. What's not right? What's the symbol for B?
And
gate. And what's the symbol for C?
or
Or gate. Good. So answer there is D. Good. Item 40 refers to the following diagram. It shows an AND gate, OR gate, AND gate. Good. A and B. What is the output at C and D when the output at A is 0 and the input at B is 1? I see a response here. B. B is correct. Well done, Daniel. All right, let me work out why it is indeed B. We have the inputs A and B feed into both the AND gate, which outputs to C. And we have A and B feed into the OR gate, which outputs to D. Now you have to know the truth table for the AND gate and the OR gate to know what C and D outputs would be. For an AND gate, as I was explaining last week, the only way you can get a 1 at an AND gate is when both A and B are 1, else it will be 0. So the mere fact that A is 0 and B is 1, the AND gate output C will have to be 0. Only way you can get 1 at C is if both A and B are 1. So C there is 0 because A is 0 and B is 1. It doesn't matter if B is 0 and A is 1. Either way, only way you get 1 at C is if both A and B are 1, but they're not. So that means that C is 0. So the question is now, why is it that D is not also 0? We're not dealing with an AND gate, we're dealing with an OR gate for D output. And the OR gate says the only way you get 0 at the OR output is when both the inputs are 0, A or B. If A or B is 1, then you can get a 1. And of course, if both are 1, then you get 1. So the only way you get a 0 for the OR gate is when both inputs to the OR gate is 0. So therefore, C is 0, D is 1. So the answer there is B. All right. Remember, I said that you need to know the symbols and you need to know the truth table. Yeah, I wasn't kidding. You need to know these things. All right. 49. An ideal transformer has primary windings. Let me zoom it a bit. Oh, too much. Right. I'm gonna shift this over a bit. This mouse is not good. An ideal transformer has a primary to secondary turns ratio of 1 to 3. So it means that if the primary has 1 turn, the secondary has 3 turns. And of course, if it has 100 turns on the primary, it's 300 turns on the secondary. An alternating potential difference of 200 volts is applied to the primary coil and a resistance of 200 ohms attached to the secondary coil. What is the current in the secondary circuit? I assume that you know the ideal transformer equation. If you do not, then you cannot work this out correctly. Can somebody tell me what the ideal transformer equation is for everything, for the number of turns, for the voltage, and for the current? All right, sweetie. What's the matter?
Is that the mirror?
No, it's a camera, sweetie.
Oh, it's a camera.
Yes.
I'm on the camera too.
You're gonna be quiet? You have to be quiet, please. That was a question, you know, what's the equation for the ideal transformer? Yes, sir. You have to be quiet. You're going back to the room? Go. Yes. All right. Yes. Okay, I see somebody responding here. Was not taught. Wow. All right. All right, write this down. The best way to do it is just to write it down. What I'm gonna tell you is the worded form, but you can write it in the symbol form if you'd want to. The symbol for number of turns is capital N. Symbol for voltage is, of course, is capital V. Symbol for current is capital I. So the equation for all three is as such. Number of turns for the primary over number of turns for the secondary is equal to the voltage over the voltage across the primary divided by the voltage of the secondary, which is equal to the current through the secondary divided by the current through the primary. Let me go for a pen. So I'm gonna write it down. Okay. Write it big enough so everybody can see. And I'm gonna use sub symbols. Number of turn primary over number of turn for the secondary is equal to voltage over the primary. Voltage over primary over the secondary is equal to the current to the secondary over current to the primary. Yes, Esther?
I finished.
Yes, very good, sweetie. So I don't. Yes, sweetie, very good. All right, Esther, go and watch a video. Esther, you want more? I'm coming. I'm coming. All right, so that's the equation. All right. So the NP is the number of turns for the primary over the number of turns for the secondary. That's equal to the voltage across the primary coil divided by the voltage across the secondary coil, and that's equal to current through the secondary over the current through the primary. All right. So that's the ideal. Esther, no. Right, so where are we? So that's the equation. I take it that everybody saw that. If they didn't,
sir.
right here. Say again. You got that? Everybody see this equation?
Yes, sir.
Okay, lovely, good. Now, what does this mean? If they tell you that the primary to secondary turns ratios is 1 to 3, it means that NP over NS is 1 over 3. All right, so you can know what NP over NS is already. All right. Now, an alternating potential difference of 200 volts is applied to the primary coil and a resistance of 200 ohms attached to the secondary coil. What is the current in the secondary circuit? Now, there are two ways to do this, but well, you'd have to know what the voltages are. So you have to find the voltage in the secondary, and then, well, you already would know that. Right, so here's the thing. Knowing the voltage in the primary, what's the matter, Esther? I'm coming. Knowing the voltage in the primary coil you can know the voltage automatically in the secondary coil because you know that NP over NS is 1 over 3. All right. So if there's 200 volts in the primary, then you know that in the secondary it is 3 times the 200, which is 600 volts. But 200 over 3, 600 gives you about 1 over 3. So you know what the secondary voltage is, right? And then from knowing the secondary voltage, you can now know what the current is from the second part of it. So what you would do is that you would say, you'd highlight this section. Let me just work this out for you. You'd highlight this section. All right. You'd have to highlight that section there. All right. This section would have to be highlighted. All right. And then from highlighting that section, you can know what the current is, because they made no mention of current in it. You know, they made mention of resistance. So you'd have to apply Ohm's law to this. And you know that Ohm's law is V equal to IR. All right. So for you to find current, you would have to know how to relate that to Ohm's law. All right. Now, for you to find what the current is, you can easily find what the current is by knowing that VP over VS is 1 over 3. But for you to find the current, you'd have to know what the voltage across the secondary something is. And to know that, well, you already would know it, which is the 600 volts. And that's for V secondary. You apply Ohm's law, knowing that V equals IR. And the resistance in the secondary coil is 200, they said, 200 ohms. So to find the current through that now, you just simply transpose, and that will give you 3. Okay. So it really works out to be D. All right. So here is how it would work out. You know the equation already, right? And then from that, you could know what VS is. Once you know what VS is, then you apply Ohm's law. VS, which is the voltage across the secondary, is equal to the current through the secondary times the resistance of the secondary coil. That's Ohm's law, V equal IR. So you have the 600 volts from the ratio that you'd work it out from already. You'd know that the resistance through the coil is 200 ohms and the current is unknown. When you transpose for the voltage, so that's what you end up there, 600 volts equal to I R 200 ohms. So when you transpose to I V over R, you'd have 600 over 200, which will give you 3 amperes. All right. You could work out what the current in the primary is, but it's not necessary. So yeah, but the answer, that's how you'd get it. So there's 2 workouts, but you have to know the ideal transformer equation. You'd have to know all of that. All right. So the answer there is D for 49.3 amperes. All right. So we move on to number 50. All right, refers to the following current time graph, and it shows a sinusoidal waveform. What is the period of the current? What's the period of this current? Are person still there? I don't know. We're looking at number 50. Are you still hearing me? Are you still with me?
Yes, sir, we're here.
Okay. Just checking. Right. So oh, see our response here. Let's see what the response says. This thing is not working. All right. A. No, the answer is not A. So it's not A. Any other?
B.
B, sir, as in boy.
B, yes, B is correct. 4 seconds, because when you look at the graph, it goes from 0, half a cycle is 2 seconds, and then it goes to the full cycle, which is 4 seconds. We
Yes,
look at
sir.
the axis, time is in seconds, so that's 4.
Got
All
it.
right, 51. In which of the following circuits will the lamp light up? Zoom it out a bit. So looking at these circuits, this is a repeat question. I've seen this before. So which of the circuits, A, B, C, or D, would the lamp light up? Anybody responding?
Is it B, sir?
B?
B.
All right, let's look at B. Remember, the diode arrangement only allows current to flow one way. But this is a DC source, so the current is only flowing one way. So the question is the diode arrangement forward bias or reverse bias? To know if it is forward bias, we look at how it is. The arrow head of the diode shows how current will flow from positive to negative. So when you look at A, the plus side of this is actually down here, so the current would want to flow down to the right, up to the left. But the diode is showing that the current is only flowing to the right on the upper section, so that would not light. When you look at C, there are opposing diodes, so no current can't flow there, because either way the current flow, it will be blocked by a diode. And when you look at D, the cells here are opposing each other. So negative connected to negative, positive connected to positive. No current can flow in that way. So the only one there is B. All right. So
I
the
don't
answer there is
understand.
indeed B. All right. 50. Oh, you don't understand. All right. Let me say again. For A, the power source, the DC power source here, the plus side of the battery is at the lower part of the power source. So the current will flow conventionally from plus to minus. So when you look at here, the current will flow from here down to the right, up to the left, and back. But this diode is arranged in such a way that it only allows the current to flow across to the right in the upper section of the cell. So that means that the current should only be flowing going around clockwise, whereas the circuit is allowing an anti-clockwise current, which is this way. So the diode and the power source are opposing each other, so no current will flow. For C, the diodes are opposing each other. So one wants to flow the current clockwise, this one, the one on the left, wants to flow the current clockwise, the one on the right, wants to flow the current anti-clockwise. So it doesn't matter what the battery is saying. The diode will not allow current to flow in either direction because of the arrangements. For D, the diode wants to flow a clockwise current, but the cells, the power sources, they are opposing each other because the negative is connected to negative, positive is connected to positive. For you to have one directional flow of current from DC sources, they must be connected negative to positive. So everything flows one way. But once you have them negative and negative, positive and positive, no current will be able to flow. Only way current flow is if one is more powerful than the other. One is pushing a stronger voltage than the other. Then it will overpower. But we assume that the power sources are the same, so they oppose each other, so no current will flow. So the only one is B, whereas the cells are going in one direction, and the current that is flowing is going in the clockwise direction that the diode will allow. Are we clear?
So the positive part of this battery should connect to the back of the diode, so current flows in that direction.
Yeah, the positive part should be behind the diode.
Alright.
Got it. Good. 52 refers to the following diagram, and it shows a fuse, a diode, a resistor, and a lamp. Question is, what is what? Which of the following options shows the correct match of the component name and its number? Number one is what? Somebody just tell me.
Number one is a diode.
Lamp.
No, it's a lamp. Thank
Lamp.
you. Number two is what?
Fuse.
Fuse, good. Number three?
Diode.
Diode. Number four?
Resistor.
Good. So we have, well, they have it diode, lamp, resistor, fuse. So diode is 3, lamp is 1, 2 is fuse, resistor is 4, and
That's
fuse
A.
is 2. So it is 3, 1,
4, 2.
4, 2. So which one is that? 3, 1, 4, 2. So that's A. All right, let me check the chat. Okay, Daniel, thank you. You are correct in saying A. So it is diode is 3, lamp is 1, resistor is 4, fuse is 2. 3, 1, 4, 2, A. Good. 53 refers to the following diagram of an AC, simple AC generator. Diagram, the parts labeled X, which is this and that. Got the arrow lines are dull, but actually arrows pointing from X to these things here. So in the diagram are known as what?
Slip rings.
Slip rings is correct. Thank you very much for that, Shanti. So D is slip rings. Which of the following statements about radioactive decay are correct? This is a repeat question. No, I don't know. Well, it might ever repeat or not. I want to find out what it's saying. Yes, so which of the following statements about radioactive decay are correct? Is it a random process?
Yes, sir.
Not sure. All right, yes it is, Shanti. It is a random process. Is it dependent on conditions external to the nucleus?
So we're at 54.
Hold on, wait, what?
We're at 50.
Oh, sorry. So true. Yes, half-life is defined as?
That's A.
Time it takes for half of the radioactive atoms in a sample to decay. Let's look at B. Time it takes for the radioactive atoms in a sample to decay, no. Half the time it takes for the radioactive nucleus to decay, no. Half the lifetime of a radioactive sample, no. So it is indeed A. The time it takes a half of the radioactive atoms in a sample to decay. All right, so that is correct for A. All right. I don't know if that was meant for 54, Daniel, but the answer there is A. Time it takes for the radioactive atom, no. Half the time, half-life. 55, which of the following scientists discovered the relationship E is equal to mc squared? If you're a physics student, you should know this.
D.
D, Mr. Einstein, excellent.
Yes, sir.
Which of the following cannot be deflected by a magnetic field? All right, I see a response here. B, no, it is not B. If that B response was for 56, it is incorrect.
Is it C, sir?
Are you guessing?
Asking.
That sounds like a guess. It's a correct guess, but you need to know why. All right, here's the thing. A magnetic field affects magnets and it also affects charges. Remember electromagnetism?
Yes, sir.
A magnetic field can induce a current, and a current has an associated magnetic field. So the term electromagnetism is as a result of a mutual interaction that exists between magnetism and electricity.
Yes,
so
sir.
once you have a magnetic field will affect a magnetic material, and it will also affect charges. All three, alpha particles, beta particles, electrons, they're all charges. So they will be affected by a magnetic field. Gamma rays, they are uncharged. They're just energy. So they are unaffected by a magnetic field. 57, this is a repeat question. Everybody should be able to work this out, I hope. How many protons, how many neutrons does the nuclide for thorium-234 have?
It has 90 protons and 144 neutrons.
All right, how do we get the 144 again?
That would be the proton subtracted from the mass number.
All right, so 234 minus 90 gives us 144. And mass number is the sum of protons and neutrons. So to get the neutrons, we simply take the proton from the mass number. All right, now we're on to 58. So we said that it is a random process, but we weren't sure if it is dependent on the conditions external to the nucleus. Is it dependent on the conditions external to the nucleus? Yes, no, maybe so.
No.
All right. No, it's not. So sorry, Daniel. It is not dependent on the conditions external to the nucleus. For a nucleus to decay, it is not dependent on what is happening outside. It is only dependent on what is happening inside. All right, so it doesn't matter if all hell is breaking loose or there's calm outside the nucleus. What causes it to disintegrate is whether or not the nucleus inside itself is unstable. If it's stable, then it stays. If it's unstable, then it breaks apart.
Yes, sir.
That's not external, that's internal. So the only answer there, it is due to changes in the nuclei, yes. Is it a random process? Yes. Is dependent on conditions external? No. So the answer there is 1 and 3, which is B.
Got it.
N not radioactive nuclei present in a sample at time equal T0. Which of the following best represents the variation with time of the number n of undecayed nuclei present? So we start with N naught. We're looking at now how N, which is the undecayed nuclei.
Daddy, the phone, it died.
The battery died? All right, you'd have to come and let daddy plug it in. Carry the phone to daddy. Right, so where are we? Right, so we're looking at now the variation with time of the undecayed, meaning that everything was undecayed before, but now some decayed. So they're looking at now what remains. All right, this is a repeat question, and I think it was the last question on the 2018. And the answer there being D is correct. Remember, it was the exponential decrease, right? Yes. Okay. Where is this? So, the number. So just go to the bathroom. So. So yeah, the answer there is D. Let's look at 60. While I bring this. Okay, good. Let me just zoom this up so you can. It's a workout question. Zoom it sufficiently so everybody see. So which of the following equations is correct? Work that out on the back. Let's come. Put it back. Right, so what is the response for 60? Still have more work it out? All right. Let me see. All right. C for 60. C. Let's look at C. Yes. C looks correct, but let me check out A. A and C are similar, but the particles are different. But for a beta particle, it doesn't cause the numbers to change as they have for A. Let's just stop, please. Don't make any noise. So A is out. Let's look at B. A beta particle means that the proton number will increase and the mass number remains the same, but the mass number changes for B. So as a result, you do not have, that's not what is reflected for a beta decay. And for D, it's the same thing, but an alpha is emitted. So really and truly, the best one is the alpha, in which the alpha particle represents a decrease of a mass number of 4 from 226 to 222, and a decrease in the proton number of 2 from 88 to 86. So the answer there is indeed C for that one. All right. Now, yes.
So for beta, it's 0, -1, right?
Yeah, the symbol, how it's written is 0 at the top and -1 below. Yes.
So carbon would be 14, 5. If you to be correct.
No, man, it would actually be if carbon undergoes beta decay. But yes, I think so. Yes, sweetie, I'm coming. I'm coming. Yes. I'm coming. I'm coming, Esther. I'm coming. I am coming. Wait. Right. As I was saying, with regards to carbon 14 undergoing beta decay is reflective of a neutron. I'm coming. A neutron becoming a proton and emitting an electron. All right. So if the neutron becomes a proton and emits an electron, the mass number doesn't change, because it's just neutron becoming proton. All right. So the mass number is unaffected. However, the proton number goes up. So what would happen is that if this was a true beta decay, then the 14 would not change, but the 6 would become 7. So it end up with nitrogen being 14 and 7, which really is what does happen. But the mere fact that it is 15, it makes it incorrect to show that the mass number changes as well. So that is why it is not B. And of course, it's not D because an alpha particle will change the mass number by 4 and the proton number by 2. By that, it will decrease the mass number by 4 and decrease the proton number by 2. So the only one that shows it correctly is C. Because for A, the mass numbers changing and the proton numbers changing is not by way of a beta. It's by way of an alpha. All right?
Okay, sir.
Right. So my question though, the emails that I had sent to the persons, were you able to access the past papers? For those who saw the emails?
No, sir.
You were not?
No, sir.
Yeah, I suspected, because what happened is that when I was sending the files, Esther, stop. What? It's mommy's pen. When I was sending the files, it told me that yes.
I want to have it.
Here. When I was sending the files, it asked me to put them to a Google Drive. Got it? Any file larger than 25 megabytes, it was automatically transferred to a Google Drive. And I kept getting emails about requests for access, and I kept giving the request, but I wasn't sure if persons had gotten the files themselves. So the only way I can see, gosh, I don't know if somebody could suggest something right now as to how you can get access to those files. Any suggestions?
You got it.
Esther Marie, be quiet. Nobody has any suggestions as to how we can get around this? Nobody? Okay. Well, what I'll have to do, I'll probably have to go back into my email and see how best I can make it available to persons. All right. Are persons here? I don't know. Are the persons here?
Yes, sir.
Right. So what I'm saying is that I'm gonna have to check in my email box and ensure that persons have access to it. All right.
Okay, sir.
All right. When did you say the exam is? The 21st? Is it on the 21st of July? I'm not sure.
The 31st.
The 21st or the
31st. 31st.
Oh, the 31st.
Oh, the 21st. How?
Oh, so that's the end of July then, last day of July.
When I see the video,
All right. I don't know what date that is, but Esther, be quiet, please. I'm gonna work and ensure that you have the files available to work
It's a Friday.
on. It's a Friday. The 31st is a Friday.
Yes, sir.
Okay, yes, I'm coming. Right, so I'm gonna try to see if I can make those files available to persons as soon as possible. All right. I don't know if it's a case that, well, we went through the questions and for the most part, persons got the answers, and I hope that the explanations given were also clear to persons as to how we were to work these questions out. All right. So pretty much right now, we've worked through the 2018 and we worked through the 2019. Esther Marie, be quiet, please. Persons are seeing you, Esther. There are persons seeing you right now. Persons are seeing you. Right. So as I said, we can dialogue via the email section, or we see how best I can. I don't know. I don't know if WhatsApp would probably be better. I'm not sure. But I want to ensure that if you want any assistance further, that you can message me, contact me in whichever way possible, so as to give you the feedback that you may so need to ensure that whatever you're working on is correct. Esther, be quiet, please. All right. So I don't know if you have any other classes scheduled for today, but that's us for now. All right.
Sir, when again you gonna have class?
Say again?
So when again you gonna have class?
Well, you see, that's the thing now. As you can see, the host of it is the Mictown district. So as it is right now, it would really have to be, as I said from the last time, to know what has been so structured with regards to the members or the leaders of the church. Because as it is right now, yes, sister?
I want a bigger help for me.
Yeah, I'm coming.
Daddy.
Yes, Esther Marie?
I want that. I want a bigger one. A picture, Daddy.
Yeah, I know, I'm coming. Right, so I'd have to speak with my pastor and elders to see if such can be arranged and when. All right? I
Sure.
can't
Sure,
just say, all
because
right, do
this
this. Say again?
because this is the last class I'm doing with that.
Yeah, that's what I'm saying. So if it's a case that persons would want to communicate via the, because I sent them an email and I'm gonna send it again just for clarity in the text section. All right, so if it's a case that we'd want to speak via WhatsApp, then you can just email me. Hold on, wait. I don't want it to go to her. Everyone in meeting.
Daddy.
Yes, sister?
I want a help for me.
Yeah, I know, sweetie, I know. Right, so I'm sending my email as well as my contact
1, 2, 3, 4, 5, 6,
for WhatsApp.
7, 8. Esther.
Right.
My name.
Right. So that's sent for everyone. So that's my email, that's my WhatsApp.
Daddy.
Yes.
I want a bigger one.
Yeah, I know. So you can contact me either way and see. I think the WhatsApp would be better in terms of giving you the files, because that's how I got them. So once you have WhatsApp, I can just easily drop them somewhere and you can access them on the WhatsApp channel. All right. And of course, if that's not more convenient for you, then you can just email me. But beyond this point, there's no surety that there will be another class like this, and hence any more communication would have to be on a one-to-one or in a group basis thing. All right?
Stop.
That's saying not behaving. Persons are seeing it. They're seeing it right now. So I hope that persons benefited this afternoon from it.